I introduce Alan Roble, he had asked me if I would just give a little introduction to his presentation by just speaking about the distribute function. So I'm just going to, this is going to be used as a setup for his aggregate function to help explain a little bit more. So let's start with this concept of cluster skew. Let's say that you have a 3-node training cluster and you're working with a 300 record set. So optimally, we'd like to have 100 records distributed across every node in the cluster. However, as we're looking at the graph of the job, we start to see these numbers pop up. Now, by the way, these numbers used to appear in between the edges of the graph. They used to be right on the graph, right up front, and a lot of people didn't know what these numbers meant. Now in version 7, if you actually click on the process of the graph, it will actually tell you the skew at that particular time. So in the new graph control, you'll see by just clicking on the graph process, the actual square job, you'll actually see a pop-up window that pops up all the information about that particular point of the job. So anyway, we see a skew here of 200% and 100%. What does that mean? Well, of course, it means that one node is actually doing 200% more than it should be. So 200% of 100, of course, is 200, and 200 plus the 100 norm will give us 300 records on that node, which of course means that the other 2 nodes are sitting around idle doing nothing. So this is where we have, in a distributed data system, a very inefficient use of the nodes where one node is doing all of the work. And so the solution for this, when we encounter cluster skew, which is actually resulting in the slowing down of our ECL process, is the distribute function. So the distribute function saves the day. It distributes records from the record set across the nodes of the target cluster based on whatever method you want to choose. And the distribute function also recommends that your subsequent operations then, once you've distributed the data properly across all the nodes, then local operation can be achieved. And of course, local operation uses the word local on many of our transformation functions and sorting and roll-ups and dedupes and things like that. They all use, and projects and iterate for that matter, just about anything that can transform data or sort data has the local option. And just for your reference, there are 4 types of distribute methods. The first one is kind of like just distribute the record set. You don't really know or care how you want the records to be distributed, so it will distribute by the hash of the entire record. That's just the default, what they call the random distribute. The second type of distribute uses an expression, and in our classes we like to talk about the hash functions used as the expression to give you a more accurate hashing, especially if you're combining different fields together in your distribute expression. So for example, you're using a company name and a first name and a last name. It's more efficient to use the hash value of those combinations, which breaks down to only 32 bits, where if you had strings that you were distributing, you could have a much larger distribute there, a lot more inefficient type of distribute. So the hash functions available, just to quickly show you this, you've got hash and hash 32, 64, CRC, cyclic redundancy checking, and then MD5. That was, for some people, that requires a 128-bit algorithm. But remember, keep in mind, at the end of the day, they all get reduced down to a 32-bit algorithm. A couple more methods of distribute. One I haven't used too much, but I thought it was interesting, index-based distribution, where you can distribute by the value of an index and the join condition of the whatever search terms you have in the index determines how you're going to distribute the target record set across the nodes. And the last one is one I've seen a lot in our production day-to-day operations in LexisNexis, which is kind of almost like a safety valve, where you're not sure, based on a join operation or some kind of normalization, denormalization, you're not really sure how the distribution across the nodes will happen afterwards. So you can set what they call a skew method, where if the records are skewed, then and only then will the records be distributed. So the skew, the skew number here, the formula that you see down here is calculated, and just to break it down, make it really easy, it's a percentage. So if you do 0.10, they're saying anything over 10% skew, redistribute the data. 0.3, 0.4, 40%, 30%, and so on. So that's the skew-based distribute. So once again, distribute is a function that you use in a couple of conditions. Number one, if you have, if you're noticing slow performance in your job, you might want to take a look at the graph and see if you can determine any kind of cluster skew along the way. And at that point in time, that's where you probably need to issue a distribute. Like I said, I like to use the second method that's using the hash function, but I see a lot of people using the skew, just like I said, as a safeguard, where that if the data is automatically not skewed, it doesn't have to do a distribute, but if the data becomes skewed, then the distribute will automatically happen. So that's my part, just introducing the distribution.